This is quite an interesting question. Solve I to the power of z equals root 3 plus I. Now, the fact that it's a complex number seems to throw everybody, but in actual fact, the way we're going to solve this is pretty much identical to the way that we would solve it if z was not a complex number, but if it was real, by taking logs. Taking logs of complex numbers, in some measures, is actually easier than taking logs of real numbers. So if we just let's just have a very brief recap of let's imagine that we had I don't know, log of 3e squared, for example, where these are real. 3 is real and e is real. So what we would do is we would, using log a, log ab is log a plus log b. We could say that that's log 3 add log of e squared, and the log of e to the power of anything is that. So therefore the answer is log 3 add 2. Okay, that's the answer to log 3e squared. Now, when we're dealing with complex numbers, fortunately, we have already discussed in great detail how to convert the general form of a complex number, a plus ib, into the exponential form, which is going to be re to the I theta. Now, when we then take logs of re to the I theta, it is exactly the same as taking log of a real number. So the log of re to the I theta, which is a complex number, is log of r plus I theta, for exactly the same logic as we've just done in this calculation here. So in actual fact, taking logs of complex numbers is extremely simple. So let's look at the question in hand, which is I to the power of z equals root 3 plus I. We have three complex numbers, z, which is what we've got to find. We also have I, and we also have root 3 plus I. So let's put I in exponential form. Well, I in exponential form is 1e to the I pi over 2. We don't really need the 1, but let's put it in anyway. And root 3 plus I is 2e to the I pi over 6. Again, these are two of the 16 well-known complex numbers that we have to be able to convert between general form and exponential form. So we can now rewrite our equation as e to the I pi over 2 to the power of z equals 2e to the I power pi over 6. And we can now take logs exactly as we would if z was not complex, if it was real. So we have z log of e to the I pi over 2 equals log of 2e to the I pi over 6. Now log of e to the power of anything is just the anything, so that's zi pi over 2, and we already know that the log of 2e to the I pi over 6 from the example up here will be log of 2 plus log of e to the I pi over 6, which we know is I pi over 6, so we can therefore write zi pi over 2 equals log of 2 add I pi over 6, and we're almost there. All we need to do now is get z on its own, so z equals 2 over I pi brackets log 2 add I pi over 6, and let's just tidy that up slightly by expanding that bracket. That will be so z equals 2 log 2 over I pi add the I pi cancels in the second term, a third, and some people think it's a little bit uncouth to have the I left on the bottom, so let's multiply top and bottom here by I, and that will give us 1/3 minus 2I log 2 over pi, and that is the answer to the equation. Okay, simple.